Are we doing Lab 7 next week? What? Oh,
I'm just playing around. We're doing Lab 6 today, and we will look at Lab 7 on Monday. If you want to come in on Friday and start on Lab 7, I'm cool with that.
was Lab 7 less intimidating than actually? It was pretty messed up.
No, this is easy stuff.
All right.
But there's a lot that we have to go through on this. This is a forward and reverse motor starter, handoff auto switch or selector switch, and then limit switches. And these interlocks here have to do with that forward and reverse motor starter. So a lot to cover before we attack that. But I know there's not going to be, a couple of people aren't going to be here today. So some people are going to need Friday for a catch-up day. But if you want to come in on Friday and start working on that, if you get 6 done today, then yeah, it's all yours, brother. Somebody was just using that for the robot, probably. Up to you. Cool. How's the homework going? We had 2 assignments done so far. Next one, chapter 4, is due a week from today, right? So we'll take a quiz on chapters 1 and 2. Let's plan to do that on Monday. Is there anything on 1 and 2 that you guys want to go over? Any questions that you had? I know since you don't have computers in front of you, it's hard to pull up your assignment. Can you do that on your phones? Do you do your homework on your phones, or do you do it on a computer? Why don't we do this? Chapters 1 and 2 quiz, we'll plan on taking it on Monday. But if you want to go over any questions that you have on any of those before we take the quiz, we can do that. So come in Monday with questions if you have them. Sound good? Alrighty. I was going to wait for Jessica, but let's go. All right. Lab 6. We'll do a quick review first. What do you see on here that has to do with the motor starter? How many different parts on this ladder diagram? Can you guys see that up there? Huh? Huh? I want to review the symbols versus the physical components. So on the ladder diagram, tell me where you see parts from the motor starter. First of all, this is the motor starter, right? You all know what this is called. It's a motor starter, right? How do we get rid of this thing? Like that. All right, so where on the ladder diagram do you see components for that?
The coil.
The coil, where's that at?
The circle.
Right. This is a symbol for a coil. So there's the motor starter coil. And on this, where's it at?
top.
Up top? Up here?
No, in the middle.
Right there, right? Those 2 pins. And all that is a wire that goes from here, goes inside and goes round, 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 round. Actually, it's a figure 8. You saw that, right? When I opened it up. And then it comes back out. All right, where else do you see motor starter components on this ladder diagram?
The open contact.
This one? Yep. Where's that on here?
The 2 and 3.
Right, normally open contact. It's called an auxiliary contact. Auxiliary just means extra. So we could put a normally open, a normally closed, and there's multiple places we could put them. But what is the purpose of this thing in this diagram? What is the point of that? What?
Break off.
To break. Yes, it will break. Remember what this is called? It's called holding contact or a seal-in contact. So that when we push this button, the coil gets energized, this changes state, and it keeps that parallel path going and keeps the coil energized. Right? Good. What else? Where are the other parts of this motor starter on the ladder diagram?
Overload.
Overloads, right yonder. There's one more place.
Contacts might be overloads.
Yep. These 3 normally open contacts. And up in the power circuit, this is what we're trying to do, right? We're trying to get that motor to turn on and off. We close these contacts by energizing the coil. We close this contact by energizing the coil, right? So along with the motor starter, we have some other components that we're going to talk about next. Remember before I had you cross out on the first ladder diagrams, it said CR1, CR, control relay. This is a control relay. And there's all sorts of different types, and we'll cover a few different kinds in this class. But this is pretty common, pretty standard industry control relay. This is actually the same thing as this, but much simpler. Matter of fact, this is one of these, except it has stuff to protect the motor, right? That's the only difference between this and this. But it operates in the same way in that there are contacts on here, and this one comes with 4 sets of contacts, and that is these guys, all these vertical sets. And I'll take this thing apart too so you can see how it works. But some of them are normally open and some of them are normally closed. The coil for this is these 2 screws up top. If you turn this thing up on its side, you can see where it says the rating for the control relay, and it's a 120 volt coil. "60 hertz. So when you put 120 volts on this coil, it creates enough electromagnetism to pull the contacts together. Well, not pull the contacts together, but it pulls the 2 pieces of iron together, and it changes the state of all 4 of these contacts. So if all of these were normally open, when that coil gets energized, and you'll see this red indicator, when that coil gets energized, gets pulled in. There's a spring pushing it out right now, but when that goes in, it changes the state of all 4 of those contacts. So if all of these were normally open, when the coil gets energized, they all become normally closed. Okay? So on your print, you see the coil for control relay 1? Right there. And that's going to be these 2 screws. And then there's only one contact that we're using for this one. It's right here. So basically what this is designed to do is have a control relay that will energize, and then at the same time, this green light will turn on. If that control relay is not energized, will any of this stuff work? 50-50 shot. If that control relay is not energized, will any of that stuff work? No. So this is like a kind of like a system on control relay. In other words, if you had a few different motors or a few different processes in a system and you didn't want any of them to work until you hit system on, you could use a control relay. So if we had 20 other rungs underneath there coming off of this line here, none of them would work until this is energized. Do you see that? Right now, nothing down here is getting 120 volts because this is open and this is open, right? But how this is going to work is you're going to press one start push button. It's going to energize this, the coil, those two screws. This thing's going to pull in. You're going to wire these two wires up to a normally open on that control relay. So when the coil gets energized, this closes and all this becomes hot, right? Up to that point, none of this stuff is going to work. You see that? Once those wires are energized, you can then press this push button and turn the motor on, but you wouldn't be able to until then, right? Everything down here is everything you've done before. It's just our wire numbers are going to be a little bit different. We're adding this control relay in first. How many different push buttons do you see on here? Huh? 3. Stop. Is that normally open or normally closed? Normally closed. You have a start. It's normally open. Then you have another start, normally open down here. You can label this whatever you want. But a normally closed and 2 normally opens. And I don't care if you use green for this one, black for this one, or both of them green. I don't care what you use, but they have to be normally open, right? Or this isn't going to work. You could call this one like motor. Cool. Let me demonstrate for you real quick. Open this up and show you the guts of it. Screwdriver. Here it is. Oh. You take this cover off. It'll give you access to all these different sets of contacts. How could you tell if these contacts were normally open or normally closed? With your meter. You want me to do that? Good, because I will. All right, 4 sets of contacts. 1, 2, 3, 4. Took my meter. We got a meter handy. Really confused where my meter went. Did I let somebody borrow it last week? No? Okay. You guys are really, really into this today, I can tell. Huh? Wake up. What the? Okay, first set of contacts. Is that normally open or normally closed? normally open. And I push this thing down, and I get nothing. Why? So I am getting a reading. And then I push it and I get no reading. So that one's actually normally closed. This one should be normally open. Why am I not getting a reading on this? I think the contacts just are either not clean or not giving me a good enough tone. Let me try it this way. Why? For some reason, where these things are corroded enough, they're not giving me a tone, but they're just giving me a reading. But try to get a clean one. So that one would be normally closed, right? And then these ones would be normally open. You bastard. Get on there. You remember me telling you about NEMA style components that you can take apart and replace things? Since these contacts are getting so dirty, I might want to get in there and clean them or replace them. But I wanted to show you a couple of things, not just how they work, but that you can change these. So if this came as normally closed, open, closed, closed. You see how this one looks a little bit different than the other ones? You can actually take these out and flip them around. The other thing that you can do, which you'll probably do because you have good eyes, is on the top of these things, there's little tabs. I don't know if you can make that out. Can you see that or no? I don't know if you can see that, but that is a normally closed symbol. It looks like this on there. It's been corroded and worn down and everything, but it looks like that. Okay, so that would be the same as this guy, it's just sideways. So this would be normally open, and this would be normally closed, right? This is a normally closed contact. Next to it is a normally open contact. It's hard to see on the camera, but it looks like this. So that's why that second one looks different as well. All of these things don't look very easy to read, but on yours you see that one says normally closed. So you can use your meter, and I wasn't getting a good tone because these contacts are all corroded. But you can use your meter to figure out which is which, and you can also look at those little tabs. So that, where are you at? That one is normally closed. Normally closed. Normally open. Normally closed. Let's see if the back sides of these things are any clearer. To change these out, if I wanted to make, let's say this far one on the left, normally open, take those two screws out. And just flip it around. Okay, so here's the contact itself. It is normally closed, right? How it sits. Do you remember how I pushed this thing in to simulate the coil being pulled in? So this is how it operates. There's a spring underneath this red indicator that pushes the bottom contact out. So when the coil gets energized, it pulls this in against that spring. The reason that this is open or normally closed right now is that the back side of that is pushing this little white guy up, and it's making contact between this point and this point. And I don't know if you can see it in there, but there's a little plunger that makes contact between those 2 points when it pushes up. If I flip it around, it's the same thing, but it's operating backwards. So right now that spring is pushing it open, and then when the coil pulls in, it pulls that down and makes contact between those 2 points. Does that make sense? On the back side of this thing, you can see the little symbol a little bit better. I'll try to zoom in on it. See how it says normally open on there? On the front side, it says normally closed. It's just really dirty. Things I've seen some years. But anyway, that's how this thing operates. To get at the coil, if you were going to replace the coil or see how this thing operates, after you get the cover off, there's 4 screws, 2 here and then 2 on the top to take the whole top casing off, and that will show you what the coil looks like underneath. It's the same thing as this motor starter coil. Remember I pulled that out, and it's like a figure 8. It's got a couple pieces of iron that are sticking through the holes. Same kind of thing. But that is how these control relays operate. The IEC ones that we'll start using next week, the gray plastic ones, are smaller, more compact, but they're usually not serviceable and changeable like this. So like I wasn't getting a very good tone on these contacts if I was having issues with like, let's say when the coil got energized and it wasn't holding, maybe that one of those normally open contacts was kind of corroded. I could take it off of there and clean it and put it back in to make better contact. Those IEC relays, usually what you order is what you get, and you can't really change them. And you'll see that next week when you go to wire something up. If the print says normally open, you have to look on your IEC relays to make sure you have a normally open contact on there, because you can't change them. Follow? Cool. Still don't understand why I'm not getting a good tone on these. Do you have other meter leads that are don't have this little plastic deal, or does that? You don't have to look for them now, or does this thing come off of there?
I have no idea.
Okay.
The other ones are the best.
I like these little alligator clips. I like those too. I like these little safety things that go over there when you're like digging around in a cabinet or something, but I never know if it's making good contact or not. Anyway, questions on how those things operate? Are you good?
Oh, there's your read.
Where?
Recognize you. On top of the switch.
I know. I was just seeing if you're paying attention.
Oh, okay. What was that?
You're saying the same thing for me. I'm getting a resistance value, but there's enough impedance and corrosion that it's not giving me a tone. It's not happy. But there's contact, and then when the coil pulls in, opens up. Yeah, enough of that. Let's go over numbering real quick. You guys confident in your numbering to where you think you could do this by yourself? Yeah? All right, where are all my ones?
Going all the way to stop on the left side.
One. That little jumper wire should already be in there for you. One all the way to the stop. Where are all my twos?
Everything right side until it hits something.
Correct. And what's another name for all the twos?
Neutral.
The neutrals. All right, between the stop and the start, 3 there. And the next number would be 4. So there's a bunch of them here, right? All of these. They're all in the same potential, meaning one of them gets energized, they all get energized. And you're going to have to be careful when you do this that you make sure that all the 4s are connected together. What I mean by that is I've seen it happens every semester. Somebody will hook all these 4s up and turn it on and everything's wired right, but let's say the motor starter doesn't turn on. So if you go through all these and you put a wire from the start to this coil, and then another wire from that coil to the green light, and then another 4 from the start to the normally open, and and then you put another wire and label it 4 on both sides, and you go from that start to the motor starter normally open. Right, they're all labeled correctly, they're all wired correctly, but they're not all wired together. So you could turn this thing on and your control relay will turn on, but nothing down here is going to work, right? Because they're not connected. They're not all on the same potential. The other thing that I've seen so far is that sometimes we're putting a wire 3 and a 4 together. Would you ever have 2 wire numbers on the same terminal? Nope, never. That makes the other side of this a 5. Five, 5, and 5. Cool. I'm going to do a little demo, and I'm going to go through this kind of quick as long as you're understanding it. If you have questions, though, please let me know. And I'm not going to number these to save time. But remember, the rule of thumb is 1 wire at a time, number each end, check it off on the print, and then move on. Cool? All right, so where should I start? Where should I start? Wire number 1's, right? Yeah?
Yeah.
You guys want me to do this, or do you want to just go?
Go ahead and do it.
Let's do it. All right, wire number 1 from the transformer to the fuse. This little guy right here. It's already in there and done. In there, numbered, and done. So I can go like this. Badoop, badoop. From the other side of the fuse, wire number 1 going to the stop push button. Right now, mine is going to start, so I need to change that. Real quick, stop push button out, so I need to make sure that I'm on the right stop push button. Ooh. I'm not on the right push button. So I have continuity on these right 2 terminals. So I need to move it to this stop push button. Follow what I'm saying? One wire at a time. I labeled it. This wire is done. Ba-doop, ba-doop. All right, the other side of the stop, I need a wire number 3 going to the start push button. It should be right over here. Make sure these 2 are the right push button that I'm talking about. Use my meter. Should have no tone. Then I push this. It's going to be this push button right here. Little jumper wire in there. Wire number 3. Put numbers on both ends and then I mark it off. So I just put this little jumper from there to there in. What's next? Can you see that okay? So what should I do next?
Snare one.
Hmm?
Snare one.
Yeah. But why wouldn't I go over to the other side of the start button first? Could you do that? Was it number 4? Yes. But I would recommend you do all the same wire numbers first. So get all the 3s out of the way. So CR1 normally open. Where's that? Mine is right here. Looks like the same thing that I showed you earlier, right? And all I have to do is look on this guy and figure out which ones of these are normally open. On mine, looks like this first contact is, I'm going to test it. No tone. I'm going to push that red guy in and I should get a tone. So the one on the far left is normally open on mine. So I need a wire number 3 to go from one of those push buttons, doesn't matter which one, over to a normally open. Does that make sense? Yeah? No? Yeah? Are we following me or no? We need like a dad joke, or you guys are just... Anybody know any good dad jokes? This is the funnest class I've ever had. Huh?
You're welcome.
You're welcome.
I think by definition it's supposed to be bad jokes.
Yeah? Wait, was that like a double standard dad joke itself?
You just never know.
See, that's pretty good. I like that. Do this so you can see it. Does it matter if I put this thing in the top or the bottom?
Keep
The
one
contact? Huh?
in- Want it in the top.
Why?
It's closer.
It's closer. That's a good answer.
Because she said so.
Remember we talked about line side versus load side? You typically want something coming in to the top and going out the bottom, but it does not matter. If it makes more sense for you to come into the bottom set, it doesn't matter. Okay? So this guy is done. Now we can move on to the number 4s. So I know I need a number 4 at 2 different push buttons, and the push buttons are kind of close to each other in real life, right? So two of these things are going to need a number 4. So I'm going to start with a little jumper wire that goes from this 4 down to there. The other side of the start going to another start push button, which is going to be this guy. So this is the other side of the first normally open push button to one side of the next normally open push button. I put a 4 on both ends. And then I go bloop, bloop. Helps if you make that sound while you're marking it off on your print. All right, where else do I need a number 4?
Motor starter contact.
Motor starter normally open. Right here. And where can I get that from? Where can I get it from? Okay, well, I'll just start there then. I'll put a wire in there and I'll label it. I won't label it, but I'll pretend that I labeled it a number 4.
Put it on either one of the push buttons.
Yeah. Either one of those push buttons that I already have a number 4 in, right?
Mhm.
So I got one normally open and I got one connected to that number 4, which means this guy is done. Bloop. Where else?
CR1.
CR1 what?
Control relay of the coil.
The coil would be this one, right? On here, it's this